Hello, welcome to Azure Cloud Channel. In this module, we will talk about Azure Data Platform end-to-end, and I will go through the architecture and how to pull the data from the relational databases, semi-structured data sources, and non-structured data sources, and streaming. And I will talk about each architecture component in detail. This solution architecture demonstrates how a single, unified data platform can be used to meet the most common requirements. So how to pull the data from traditional relational data pipelines and big data transformations, unstructured data ingestion, and enrichment with AI-based functions, stream ingestion and processing following the Lambda architecture, and serving insights for data-driven applications and rich data visualization. So in this architecture, we're using components Azure Data Factory, Data Lake Gen 2, Azure Synapse Analytics, Azure Databricks, Azure Cosmos Database, Azure Cognitive Services, Azure Event Hubs, Azure Stream Analytics, and Microsoft Power BI. If we see it in the architecture, so we have data coming from different sources, relational databases, semi-structured, and non-structured. To bring this data from these sources, we can use a data factory and we can schedule event triggered for data ingestion. So let's talk about how to bring the data from relational databases. We can use Azure Data Factory pipelines to pull data from a wide variety of databases, both on-premises and in the cloud. The pipelines can be triggered based on a predefined schedule in response to an event or be explicitly called via REST APIs. And we're still part of the Azure Data Factory pipeline, and we can use Azure Data Lake Store Gen 2 to stage the data copied from the relational databases. And we can save the data in the delimited text format or compressed as Parquet files. And if we have data more than 250 GB, then we can choose this Azure Data Lake storage. And if we have less data, if we have less than 250 GB, then we can go for Azure Blob Storage. And how to create this Azure Data Lake Store Gen 2 and Blob Storage. When you are creating a storage account in Azure, so if you enable the hierarchical namespace, then it will make it a data lake store. If you don't enable it, then it will take it as a blob storage. So once we bring the data from relational databases to Azure Data Lake Store, then we can use Azure Synapse Polybase capabilities for fast ingestion into our data warehouse tables. And we load relevant data from the Azure Synapse Data Warehouse into Power BI datasets for data visualization. And let's talk about how to load the data into Synapse using Polybase. And I have one video module available, a couple of video modules that shows how to load data from Data Lake Store 2 into Azure Synapse. So we can bring the data into a temporary table, from temporary table to staging table, and from staging table to we can load into production. There are 3 indexes then we can choose. For large tables, we can choose hash distribution. For small tables, we can choose replicated distribution. And for staging tables, we can choose round robin. So once we have this data in Synapse, then We can load relevant data from the Azure Synapse data warehouse into Power BI datasets for data visualization. Power BI models implement a semantic model to simplify the analysis of business data and relationships. And business analysts can use Power BI reports and dashboards to analyze data and derive business insights. So if you see in the architecture, so the relational databases, we bring the data using Data Factory and load it into Azure Data Lake. And from there, using Polybase, we load data into Azure Synapse. If you see it in the diagram in the middle, fast load data with Polybase. And Power BI connect to Azure Synapse and for the data visualization, so that business analysts can use Power BI reports and dashboards to analyze data and derive business insights. And let's talk about next one, semi-structured data sources. How to bring the semi-structured data sources into Azure. How to bring the semi-structured data, even if it is on-premise or in the cloud. We can use Azure Data Factory pipeline to pull data from a wide variety of semi-structured data sources, both on-premises and in the cloud. Example, we can ingest data from file-based locations containing CSV or JSON files or text format or any format. We can connect to NoSQL databases such as Cosmos database or MongoDB. Or we can call REST APIs provided by SaaS applications that will function as our data source for the pipeline. So we can bring any of these files, CSV, text file, or JSON files, we can bring that data and we can connect to NoSQL databases such as Cosmos database or MongoDB. And once using Azure Data Factory, we can bring that data into cloud and then store it into Azure Data Lake Storage Gen 2. Now we have this data in Azure Data Lake Store. And we can use Azure Data Factory mapping data flows, or we can also use Azure Databricks notebooks to process the semi-structured data and apply the necessary transformations before data can be used for reporting. So once we have data in this data lake store, then we can use either Azure Databricks notebooks or we can use Azure Data Factory mapping data flows to do the transformations before data can be used for reporting. We can save the resulting data set as Parquet files in the data lake. And same thing, so we can use a Polybase to bring the data into Azure Synapse. Once we have data in this Azure Synapse, then we can load relevant data from the Azure Synapse data warehouse into Power BI datasets for data visualization. So Power BI models implement a semantic model to simplify the analysis of business data and relationships so that business analysts can use Power BI reports and dashboards to analyze data and derive business insights. Now let's talk about how to bring the non-structured data into Azure. So far we discussed about relational databases, how to bring the relational databases data into Azure, and how to bring this semi-structured data into Azure and where to store, and after that, how do we connect to Azure Synapse Data Warehouse, and how do we build the reports. So the next one, non-structured data sources. We can use Azure Data Factory pipelines to pull data from a wide variety of unstructured data sources. So we can use both on-premise and in the cloud. And we can ingest video image, or free text log data from file-based locations. When we talk about non-structured data, so it can be audio file, video file, image file, or web logs. And we can use this Azure Data Factory to ingest data into Azure Data Lake Store. And once we copy that data into Azure Data Lake Store, then we can invoke Azure Databricks notebooks from our pipelines to process the unstructured data. So when we choose Azure Databricks notebook, and we can choose 4 languages. So it offers Scala, Python, and SQL. So we can choose any language to do these transformations. And also we can use Azure Synapse Polybase capabilities for fast ingestion into our data warehouse tables. So once we have data in Azure Synapse, we can load data from the Synapse into Power BI datasets for data visualization. So the business teams can use Power BI reports and dashboards to analyze data. So far we discussed about relational databases and semi-structured data and non-structured data. So the last one, how do we bring this streaming data? So we can use event hubs to bring the streaming data. So let's talk about each steps. We can use Azure Event Hubs to ingest data streams generated by a client application. The Event Hub will then ingest and store streaming data, preserving the sequence of events received. Consumers can then connect to Event Hub and retrieve messages for processing. And we can configure the Event Hub capture to save a copy of the events in our data lake. So we can store the data in Azure Data Lake Store or Blob Store. Again, if it is more than 250 GB, then we choose Data Lake. If it is less than 250 GB, then we choose Azure Blob Storage. From there, once we have data in this Azure Data Lake, then we can use a Stream Analytics job to implement the hard part of the Lambda architecture pattern and derive insights from the stream data in transit. So we have to define at least one input for the data stream coming from our Event Hub, and one query to process input data stream, and one Power BI output to where the query results will be sent to. So if you want to learn about Azure Stream Analytics, there is one module available, Azure Stream Analytics. So that module tells how to ingest data, how to run the query from these event hubs, and we have to define the input and then output. So the business analyst then use Power BI real-time datasets and dashboard capabilities to visualize the fast changing insights generated by our stream analytics query. So we have other alternatives. An example, if we are getting data from the devices, then we can use Azure IoT Hub. And for big data solutions, then we can use the Kafka. So in the architectures, if you see, Azure Data Factory is the service responsible for data pipeline orchestration. Azure Databricks can also be used to perform the same role through the execution of nested notebooks. And Azure Stream Analytics is the service responsible for processing streaming data. Azure Databricks can also be used to perform same role same role through the execution of notebook. If you look at these services, right? Azure Data Factory we can use for data and preparation, and also we can do the same thing with Azure Databricks. And if we want to use for data warehouse analytics, then we can go for Azure Synapse. Azure Synapse is massively parallel processing architecture, provides scalability and high performance. Azure Synapse has guaranteed SLAs and recommended practices for achieving high availability. When analysis activity is low, the company can scale Azure Synapse on demand, reducing or even passing compute to lower cost. So we can always scale up and down. If we choose Azure Synapse, we can put 100 data warehouse units to 15,000 data warehouse units. And also, if we don't want to use this Azure Synapse for the weekend, and we can just pass it. And when we come back to work on Monday, then we can resume it. So we have this option available in Azure Synapse. And the Azure Synapse security model provides connection security, authentication, and authorization via Azure Active Directory or SQL Server authentication and encryption. And so far we discussed in this module how to bring the data from different sources, from relational databases, semi-structured data, non-structured data, and streaming data. How do we ingest this data into Azure, and where do we store? After that, which components we use for preparation and train? And after that, how to connect to Azure Synapse using Power BI, and then so that business analysts can run the reports. If you have any questions on this Azure platform end-to-end, please post in the comments. If you like this video, please subscribe and share the channel. Thank you.